Let's evaluate 1000 root of iota, but for that please do like, share, subscribe and please support this video. Before introducing you all to the 1000 root of iota, let me introduce you all to something called polar form. Polar form, okay? So suppose I give you a complex number in the complex plane. This is imaginary axis, this is the real axis, and I suppose represent a complex number a comma b, okay? So we all know that z can be written as a plus iota b, okay? Right, simple. But if I ask its polar form, how you write it? Well, it is r times cos theta plus iota sin theta, right? But how do we get this? Very simple. Okay, so this is r. R is equal to square root of a square plus b square from the distance formula, right? And the angle here is theta, right? So clearly, if you take the component of r, this will be this will be r sin theta, and this will be r cos theta. So this is equal to a and this is equal to b, correct? So from here we get this expression, right? So r is the magnitude and theta is the argument. Okay, b by a. So we will be using this polar form to derive the 1000 root of iota. So let's practice some problems and then we will be moving to this one. Okay, so let's see that. So first of all, let's solve a very basic question, square root of iota. Well, you all must have studied that write square root of iota as x plus iota y and then square both sides and then solve for x and y and you get two roots. Well, that is also a good method, but it is not generalizable. Why? Because when you try to solve these problems, it becomes very difficult. Because if you take 1000 root both sides, then there are 1001 terms. So how you can solve it? So that's why. Okay, so square root of I set it equal to x plus iota y. No. What I'll be doing? I will be writing iota as r cos theta plus I sin theta, right? Okay, so we all know that over here a is equal to 0 and b is equal to 1, so r is equal to 1 and cos theta and theta is equal to pi by 2, correct? Okay, so iota can be written as cos pi by 2 plus I sin pi by 2, and we all know that in a complete rotation the value of cos and sin doesn't change. Right? So this is the principal angle, principal argument, and this is the general argument over here. Okay, so when you take the square root, you get cos 2n pi plus pi by 2 plus I sin 2n pi plus pi by 2, correct? Square root. Okay, so let me introduce one more theorem over here, De Moivre's theorem. What is it? Suppose z is equal to r cos theta plus I sin theta, correct? And suppose I raise both sides to the power of n, cos theta plus I sin theta raised to power n, right? So De Moivre's theorem state that this will be equal to r raised to power n cos of n theta plus I sin n theta, right? How it comes? Well, we all know from the Euler's identity, cos of theta plus I sin theta is e to the power I theta, correct? Okay, so if you raise both sides to the power of n, cos of theta plus I sin theta raised to the power n is equal to e raised to power I n theta, right? Now again n theta is the another argument over here. So when you again open this expression, you get cos of n theta plus I sine n theta. Okay, understood? So likewise we can see over here square root of I is equal to cos of n pi plus pi by 4 plus I sine n pi plus pi by 4, correct? Okay, now put n is equal to 0, n is equal to 1. So when you use n is equal to 1, you get square root of iota as cos of pi by 4, that is 1 by root 2, plus I sine of pi by 4, that is 1 by root 2. And when you substitute n is equal to 1, we will get cos of pi plus pi by 4, which is equal to negative 1 by root 2, and sine of 5 pi by 4 will become negative 1 by root 2 again. Okay, so we will be getting square root of iota is also equal to negative 1 by root 2, negative 1 by I by root 2, correct? Now again, if you want to check for other values, if you substitute n is equal to 2, you again get this expression, and when you put any other value 3, you get this. Okay, so it means the square root of iota has two values, this and this. Okay, now let's move to a better problem. Second problem, suppose I ask you the fifth root of iota. Well, it's again an interesting question. So let's see. So again, I can be written as cos 2n pi plus pi by 2 plus I sine 2n pi plus pi by 2. You take the fifth root, you get it as cos of n times 2 pi by 5 plus pi by 10 plus I sine n 2 pi by 5 plus pi by 10, right? Now n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4 will give distinct roots, distinct solution of fifth root of iota, right? You can check it yourself. Okay, so if you want to check, you can write this as e to the power I, then this angle n times 2 pi by 5 plus pi by 10 evaluated from n is equal to 0, 1, 2, 3 and 4. So you get 5 different roots over here. Now let's come to this question. So let's see. So let's find the 1000 root now. So again it can be written as cos of 2n pi plus pi by 2 plus iota sine 2n pi plus pi by 2, and you take the 1000 root, you get cos of 2n pi by 1000 plus pi by 2000 plus I sine 2n pi by 1000 plus pi by 2000, correct? Okay, and again you can write e to the power I 2n pi by 1000 plus pi by 2000 evaluated from n is equal to 0 till 999. So there are 1000 different roots over here. So I hope that you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. Bye bye, take care.